All right, good day, everybody. This is Jason Strait with the Cloud Pass Virtual Group. Today we've got Chris Seferlis, and he is going to be presenting Azure Databricks, What Makes It Better. Before we get started, I do have a few announcements. So the first thing is that if you have not yet had a chance to subscribe, I would recommend that you go out to cloud.path.org and subscribe there to our newsletter. The biggest benefit on doing that is you'll find out when new presentations are being scheduled, and then also if there is any interruption to the schedule, like we did have for a couple of sessions in July, it's the easiest way to get informed of those changes so that you can make sure that you get a chance to see them at either their adjusted times or to know when they've been rescheduled to. So I do recommend people go out to that, and there's just a login to subscribe, and then you can subscribe after you've logged in out on that page. Over the next few weeks, we've got a few sessions coming up, pretty solid all the way into October now. I've got 2 more that aren't showing up on there that are filling up today. So we do have a pretty good schedule of sessions coming up, so I do recommend that people go out and take a look at those. If you are interested in presenting, there are plenty of spots still open because we are still doing 2 sessions a week. As long as I can find folks that are available. So we're looking for, if you're available, just reach out to us at cloud.path.org, or if you want to, you can go out to that cloud.path.org website, and out there is a cloud virtual group call for speakers. All you need to do is click on that link, and it'll bring you to a Google form, and you can get that filled out. This fall is Pass Summit 2019, and if you are already registered, you can go, or actually even if you aren't registered, you can go out there and take a look at the 200 sessions that were recently announced. So the community call for speakers, all of those sessions have now been announced and are out for viewing. If you have not yet registered for Pass Summit, you can get a discount to that by using the discount for this virtual group. That discount code is VGDISFKDQ. You'll see this in all of our newsletters and in all these presentations, so that's a way to get a discount on your registration. This virtual group is a number of virtual groups that helps to support. Some of these focus on language, like Global Chinese, and others focus on different aspects of data platforms, such as business analytics. It's a good opportunity to learn a lot about data platforms without having to leave the comfort of your desk. Throughout the session, you might have some questions, and if you do, I do recommend that you go out to the questions panel in GoToWebinar. In there, you can just type in your question, and then at the end, time permitting, we'll go through as questions as possible. At this point, this is all the announcements that I have for today, and so our session today is Azure Databricks, What Makes It Better, with our presenter, Chris. And I'm going to make Chris the presenter now. There you go.
I'm just waiting for my PowerPoint to reload here. I need to close it. It was displaying the runway, yep. So we'll give it a second here to come back up. It's just taking a second. As this decides to take its sweet time to load, I'll just kind of give a quick intro to myself. My name is Chris Seferlis. I'm a senior cloud solution architect over here at Microsoft in the data and AI space. Been in IT a little over 20 years, sort of held the seat anywhere from help desk right up to CIO, and sort of flipped over a few years back to the cloud solution architect ranks. Felt like I enjoyed interacting with customers and interfacing with them and working through some of their challenges. I appreciated that a lot more than trying to justify budgets and new hires and things like that. So so today, basically we'll go through sort of a slide deck for maybe 40 minutes, just kind of going through the high-level overview, some architectural stuff, some structural things, and what the main points are on Databricks. And then at that point, assuming we've got some time left, I'll do some demo inside the Azure portal itself to sort of give everybody an opportunity to kind of see firsthand what is happening there. Kind of wish I knew what was happening with my PowerPoint, but we'll figure that out here. So there we go. Okay, good. So let me load this. Of course, it came up on the wrong screen. Bear with me. Technical difficulties.
Yeah, it looks like the right slide is up. Am I sharing?
Is it a full screen slide?
Yes, it is.
Okay, perfect. All right, I'm not seeing that from here, so thank you. Anyway, okay, and then so just quick thing, social. Follow me on Twitter at BizDataViz. LinkedIn, you can get me at Seferlis. There's my email address, and then just about to launch my YouTube channel, where give anywhere from, call it 3 to 10 minute video clips on different data, Azure, leadership, strategy, speaking, kind of a little bit of everything, just based on some of my experience and some of the things that I get asked by a lot of customers and things like that. And so that'll be coming soon. You can subscribe now. We'll be doing the official launch in the next couple of weeks here. So anyway, on to it. What makes Azure Databricks better? No, that did not flip the correct one. Let's try this. There we go. Okay. Jason, you still with me? You got the right slide here? Modern data estate. Okay, awesome.
Yeah,
all right, thanks.
See the hybrid up there now.
Perfect. All right, perfect. Thank you. Yeah. So anyway, basically, our approach here at Microsoft is to look at the reality of what a lot of customers are dealing with, right? And that's this notion of what is hybrid, and how it affects their environment. And so you have a lot of different elements and I guess vectors where data is being used. It's coming and going in a lot of different ways. And so with that in mind, we try to keep all of that in perspective and how that connects between your on-premises environment, your existing data centers, your SaaS applications, and anything that's out there that really isn't now sitting in your Azure cloud. And the idea is that we want to be able to extend your data centers or your existing environment up into Azure as seamlessly as possible, right? And so that is, giving you the opportunity to be secure and have as much performance as you could need at, essentially the click of a button or a few keystrokes, right? So when we factor those types of things in, you've got this sort of natural coupling of SQL Server on-prem and Azure Data Services. Now, underneath that Azure Data Services is, Databricks, today's topic. And so we'll get into how those interact and how they integrate as we go along. Now, when we look at the big data landscape, we've got several offerings where you have this ability to you've got a lot of flexibility with the way you handle the data as it comes in, goes out, gets processed, and it really depends on what your workload, what might be the best avenue, right? We have a lot of customers that ask us, what is the correct architecture, or what are the correct components? And unfortunately, the answer is all too often, it depends. But the reality is we need to be able to align with what the workload is, right? And so when we look at sort of the top-down view of what's available, coming from left to right, you've got anything that's currently running where your data is being sourced from. So whether it be smart cars or smart meters or machine equipment that's giving you IoT data, or any of your custom in-house applications that are putting data in a repository, some database somewhere, plus your normal business applications, ERPs, and things like that. And then sort of moving from right to left, you ingest that data, and there's multiple options, whether it be Data Factory, and there are some open source options within the HD Insight space, and then also you've got event hubs and IoT hubs. You're going to store it, and that's in a data lake or a blob storage or something along those lines. And then we kind of get into this prep and train thing, right? So a lot of capability here depending on what the tool is that you need. But Databricks is definitely at the top of the list because of its flexibility. I have a lot of customers who ask me outright, what is Databricks? And so what I think is lost on a lot of people is that Databricks has a lot of capabilities, and we're going to go through what some of them are today and what some of the common use cases are. But the reality of the situation is Databricks is a collaborative environment that sits on top of a Spark in-memory processing-based data engine, right? And so what you can do with it all depends on, what language you can program in or what your requirements are. But the reality is when somebody says, well, Databricks is best for X or Y, that may be true in their case, but it really kind of depends on what those workloads are. So Spark, to give a little quick history here, was the open source data processing engine that somewhat replaced Hadoop in the big data world, right? So MapReduce was sort of some of the early iterations of dealing with big data workloads, and that was using disk-based operations. And Spark came around and said, okay, well, we're going to use memory because that's a lot faster. And so, it's this massively adopted platform where, you can see in the stats here, over 1,000 contributors to the open source data project, tons of libraries that can be hooked onto it, and support for just, numerous languages, right? We'll go into a little further detail on this. So when we look at what the benefits of Spark are is really, they had tests of up to 100x, in performance over Hadoop, and that just makes sense. You're going from disk-based operations to memory-based operations. So obviously, a lot of that comes along with just running that data through memory as opposed to write and read operations on disk. But then also, it really came down to productivity, where you've got tons of APIs that are available, and tons of interaction between Azure and the landscape, as well as what you can use for the transformation. And so some people will say that Databricks is a great ETL tool because you've got tons of transformation operations, and if you're more comfortable with the coding environment, some of those operations may be faster than running them through an SSIS or Informatica or Azure Data Factory. But it all comes down to what the skill set is too with the business. A lot of customers will say, well, should I use Databricks or should I use Data Factory? And it really comes down to what are you comfortable with and what can your team handle, right? It also has this unified engine that, like I said, it integrates directly within Azure, and so it gives us the capability to interact with the existing tools that are in Azure. I mean, a couple listed here: SQL and Stream Analytics and machine learning and graph processing, right? Those are just some of the examples, but it has great interconnectivity with many Azure services. And then really it gives you this great ecosystem where you've got a ton of support from users in the development community, and then it is available on all three public clouds, but we've got a little bit of secret sauce here at Microsoft that sets us apart. Some of that is, as I mentioned earlier, it's a collaborative environment that sits on top of Spark, and some of the real differentiators here are with regard to the way it's set up, the way that the workspaces interact, and the way that users are able to be added using Active Directory integration. Also, the native connectors with both the back-end tools, so whether you're connecting into blob storage or a data lake, and then other ingestion tools, say event hubs or something like that for streaming workloads, and then all the way through the processing, the ETL, you know, it has interconnectivity with Data Factory. You can run a Databricks notebooks with Data Factory, and then right out into dumping the loaded data or the transformed data right into SQL Data Warehouse or Power BI. So there's a lot of options there around how it gets connected, and that gives definitely an advantage over some of the competing clouds. Just a little more on what that experience looks like, right? It's much quicker to start up Spark environment. You know, compared to other clouds, you're doing everything right inside of your Azure environment, including it being a first-party service, and so all your billing goes right through your same Azure bill. You can wrap that in your Azure tenant, inside a subscription, inside a resource group, and you know, that just makes it much more easier to work with administratively. You've also got the ability to deeply integrate with Power BI, so you can connect directly into a Databricks cluster with Power BI and visualize the data that's been loaded into memory, that's been put into a data frame or a table inside of Databricks, and connect directly to it. You know, obviously, I'm a little biased on this, but the most compliant cloud by far and away. This is a fact, right? Azure has over 80 compliance standards that are met, and that's almost double our nearest competitor in that space. So it's really hard to beat and compete with that. And really, it gives us the opportunity for using the entire platform to allow for this massive scale. So how it looks in the in the landscape, if you will, is we sort of talked about where our data is coming in from, and then how do we want to use that data? And so really, we look at the ability to have a collaborative workspace for our there we go, for our data engineers, our data scientists, and business analysts. And so, you know, with very easy setup and shareability, we've got this same common workspace that all of our internal users and external can use, all with permissions from Azure Active Directory, and, you know, giving each of them their own specific required privileges, right? So a data engineer is more likely to have the ability to restart a cluster or resize a cluster, or, you know, do more of the transformation pieces, whereas a business analyst is probably going to use it whether they connect directly from Power BI or, you know, if they're using some of the visualization options right inside of Databricks, right? And so you've got this support for multiple avenues and how it can be used. When we look at how, you know, workflows can be completed, you know, whether it be multiple notebooks that are pulling in data from various sources, loading it into the memory and into a data frame, running some ETL on it, you know, very commonly can be used for machine learning and building a machine learning model, or comparing against a machine learning model for advanced analytics workloads. But this all can be scheduled. There is automatic compute resources that can be added to the clusters if required. So you can add additional clusters to, you know, handle larger data sets or, you know, more complex data loads, right? And then also there's, you know, a complete system of notification and logs that go along with it. And we already talked about the native integration with the other Azure services. And then, you know, we're offering a more optimized runtime engine because of how we're running this on our managed platform in Azure. Again, one bill, one sign-up page, and then going into your portal. You don't have to manage the servers in the background. They're all being managed by the system itself. And then we also have support for GPU-enabled virtual machines, which you know, will allow for more of your deep learning models and things like that. So now, On top of all that, Databricks itself has libraries available where if you know that you're working on artificial intelligence, machine learning, advanced analytics workloads, you can specify exactly what type of Databricks version you want to run. So in the example here, it's running Spark 2.3 with a GPU instead of a CPU for a processor. And that you can specify your version of Scala and Python and however you want to do that, whatever works for your needs. But it also has those machine learning libraries built into the tool, but also, support for other open source tools like TensorFlow, Keras, Huravad, and XGBoost, right? So just some of the examples of the open source machine learning tools that are out there and the libraries that can be brought into Databricks natively. So now when we talk about provisioning the workspace within Azure, right? So this is just a screenshot. Hopefully we'll have time. I can kind of show you what this looks like in the actual Azure portal. But essentially you're going in, you're provisioning it directly from your Azure portal. It's bringing up your workspace after it's been created, and you can specify, after the fact if you need your Azure Active Directory integration and those types of things. So you don't have to set up a Databricks account. It's all brought in to your Azure portal. And really when we do create that cluster, when we create our workspace, in the background, it's creating this driver program at the top, right? And so I kind of like to use setup like this, right? Up here in the Northeast, we've got a little bit of championship pedigree, if you will, and so my driver program is Bill Belichick in this case, and then I've got Tom Brady as my cluster manager, who's telling the offensive linemen and all of the skill players what they need to do. And they're all playing on the field, right? And so basically my cluster manager is telling my workers what they need to be doing on this play, and they're doing the work that they need to do, and Belichick is overseeing it. And so when we look at what that looks like from the architectural standpoint, once this gets deployed, on the left-hand side, you've got your Databricks Azure account that is owned by Databricks. They're not visible to you as a consumer, but this is everything that's happening on the left-hand side on the Databricks side. And then what is being deployed to your tenant is that Spark driver with the worker nodes. And so that's your Tom Brady and your skill players working in your tenant, and then all of the coaching necessary elements are all happening in the Databricks Azure account. So they have that direct interconnectivity there. Just to back up one slide, a little bit more about the cluster creation, is that you're basically, after you set up your workspace, then you're going to create your cluster in your environment. We'll do that real quick when we go through. And then you have that ability to specify, what the cluster details are, like, what the CPU is, and what versions of the different OS and applications and that you want to run, and then you can tell it to when to spin up and spin down, and there's a lot of capability there as to how you set that up specifically. So a little deeper under the covers, what's happening here is some of the orchestration, right? So through the web application and jobs that are configured within that environment inside that workspace, they're interacting with the cluster manager on the Databricks side that's doing all of the orchestration, and then basically telling which Spark driver in which cluster to run which notebook and which application operation. Now, when it comes to security, we've got the Azure Active Directory integration. It's native to the tool, basically, so that allows us to give some pretty fine-grained detail as to what users have access to when it comes to jobs and workspaces and clusters and the data. And so you can give those fine-grained permissions to users as they're needed. And it's all based on Azure Active Directory, so you don't have to set up a whole new set of permissions and user accounts. Just a little more on the Azure, on the Active Directory integration. We don't have to go and assign those. It is all enabled through single sign-on. So when you sign into your portal and you have your Active Directory tenant assigned to your subscription that Databricks lives in, you can have that integration and do some further configuration if you need to from there. And really, when we look at what the main components of the Azure Databricks environment are, it's these 5 components, right? So you're going to create a cluster, and that cluster is going to interact with all of the rest of the components here. So you've got a cluster that will be able to run notebooks. The notebooks can sit in workspaces. A job can be set up to execute a notebook, and the libraries are, these hundreds of external libraries, whether they be for existing Azure services, so for instance, Event Hub's native integration, or Azure Data Lake Store, Stream Analytics, various components here that you can load those libraries so they have direct integration with that Databricks runtime. And the jobs are just that, right? It's a job like any other job we're used to running. So we're going to execute a notebook or a jar file from Java. Basically, you're going to run this operation. You can set it at a certain time. You can set up alerts to let you know when the job is completed, successfully or unsuccessfully. Can you send you back some information about a job failure and those types of information. So you have a lot of fine-grained detail access to how you want to set those jobs up. Workspaces are really kind of a logical container. So this is a good example of a workspace where we have, a few notebook files in there. We have a few folders in there, and then what libraries are connected to this workspace. And so essentially, the workspaces are kind of a logical container. That way you can sort of assign permissions based on who needs access to what notebook or what folder. You can load some data into the folders if you want to. So there's a lot of capability there. And then once you get into the notebooks themselves, which are really sort of that development environment, you've got, this is just a good example of some SQL code that's running in a notebook file. So I'm running some SQL code in my notebook that is displaying the results of a query that I'm setting up graphically, and we've got some user interaction along the right-hand side there that shows, just some conversation amongst the team that's using this notebook. So that's a good example of what that looks like. And then language support is a big one. We have, the capability to associate basically whatever language you want to use, from the list here to that notebook specifically. But if you create a Python notebook and you decide you need to use SQL code or Scala code inside of that because either it's more efficient or it can do an operation that you couldn't do with Python, you've got the capability to run that cell specifically within that environment, and then you can execute the code based on that specific language that you want to use. Talk some about the notebooks. Notebooks are essentially that development environment that are allowing you to run the operations you want to for your code. You've got some fine-grained access control to those, and you can set those up however you need to for the users who are interfacing with it. So then, from a use case scenario, like I said, it really comes down to what user needs access to what resource. And the 3 core scenarios I would say that we get from users to request are how am I going to use this for data warehousing? How can I use this for advanced analytics? And how can I use this for stream processing, right? And so when we look at the bulk of the use cases, and again, it's a very flexible platform. It gives you a lot of opportunity to do a lot of different things, but these are the 3 most common that we're seeing from customers today. as it relates to the architecture that's being deployed within Azure, some of the components that would be involved in a big data warehouse, again, from left to right, you've got your data sources that are coming in. Anybody who's familiar with the Lambda architecture, Databricks is very well suited to handle those types of workloads where you have streaming workloads as well as batch workloads coming in into the same operation to be combined up and to be built out to a SQL to a data warehouse, right? So you've got your unstructured, structured, semi-structured data all coming in, can all be brought through with Data Factory, storing it in some type of Azure storage, data lake, or blob storage, doing any of your processing or ETL or any of those operations with Databricks, and then landing that into a SQL data warehouse or directly outputting to some type of Power BI dashboard, depending on, again, what the use case is there. And slightly different with the advanced analytics. So, in this case, the sort of the left half is pretty consistent with the previous. Now, in the right half, we're bringing on some other uses, right? And so now as we're going to start to bring in some additional libraries, the machine learning library or Spark R or Sparkly R. There's many libraries that are available for doing some of these advanced analytics workloads, outputting that data to something like a Cosmos DB where you can distribute that around the world in sub 10 millisecond, refresh times that, allows you to push data out to things like web and mobile apps and things like that. And then you sort of have your traditional data warehousing paths for any of the output there that makes sense for the workload that you're running. And finally, running real-time analytics on big data. So in this case, we're ingesting it with HD Insights Kafka. That's just one example. Certainly, Event Hubs would be a way to do that. There's a lot of capability within the Azure portfolio for running real-time workloads. Bringing that into our Databricks for any of the data processing. You might have a real-time dashboard or something like that you need to run workloads on. Else, you can bring that data into Azure Storage. In this case, you've got data coming and going to and from the Azure Storage, and that represents if you've got an existing machine learning model and you want to compare against it. With some of the real-time data for sending alerts and things like that. But then also you want to capture that in more of a traditional data warehousing form. And so you've got multiple capabilities on how to do that. Now, when we talk about specific industry uses, again, just to call out some of the ways that these are being used in more traditional industries, so for instance, in financial services, you've got effective customer engagement, you've got decision services, right? So, things like financial modeling to improve that, the outcome, risk and review management, so fraud detection, those types of things, compliance. Are we staying in compliant, running analytics on credit scores and things like that, and a recommendation engine, right? And so we'll see some of these overlap as we go into the additional lines of business and verticals, but leave that up just for a second to kind of go through, and I can make these these slides available for anybody who'd like them after the fact. We talk about health and life science. I mean, we got DNA sequence mapping, we've got real world analytics, and data claims, clinical claims, those types of things. You've got deep learning. So how are we adapting to imagery and those types of things? How can we learn from what's already been out there with regard to advanced medical care and sensor data? So picking up things off of healthcare data points, so whether it be tools or machinery out in the field and those types of things. And then obviously what's happening on social media is a big one, right? Let's listen to what the customers have to say, and let's communicate with them more quickly and make our services stand above our customers, and making them feel more comfortable that they're being heard. Media entertainment, we see this type of thing all the time with like say Netflix or Hulu. They're going to make recommendations on the things that you're watching. Customer retention, we start to see it. We just start to see customers stop watching, or they want to they want to drop off. Maybe we need to give them better options, or see how we could improve their experience. More about recommendation engines and using that with machine learning. Inventory allocation. So, what are the types of shows that people are watching, and so what should we be developing down the road to help make sure that we keep an audience? And same thing, customer engagement. Improving that customer experience, and improving the engagement with customers to understand what they want as well. So, getting some sentiment analysis from them. Retail use cases, I'll go through these a little quicker because they're a little mundane, but again, recommendation engines, improving customer engagement, inventory optimization. This one's a big one. If you hold a lot of inventory and you want to understand better ways to roll that inventory over, what are the best products to be holding for X amount of time? What's the normal shelf life for some of these products? I mean, all this stuff can be derived from, building machine learning models and gaining a better understanding of what is happening. But there's a ton of data that's related to this. So the Databricks engine has the ability to process that massive amount of data very quickly. Allocation, where should inventory live, right? So if we know that the Southwest is acquiring a certain product that we sell more often than many other regions, then maybe we should have more of that product in that area, so we can run analysis on what's happening in those areas. And again, customer engagement, right? So we're seeing this time after time, but it's, the ability to handle that real-time streaming. Customers are much more likely to be vocal. They're going to reach out through social channels, Facebook and Twitter and LinkedIn and all the social channels, and we can monitor that to find out what's happening. I've got Comcast here in the Northeast. If I put a complaint to at Comcast, I typically get a response back within a couple of hours, to be honest, because it's just something that we're getting used to being able to communicate that way to let them know that we're unhappy about something. And companies are watching this to make sure that they're satisfying their customers as quickly as they can. Advertising, so customer value, personalized offers, what's most likely to get my customer to buy. Risk management's a big one, right? So, how do we avoid fraud in these types of things, whether they be, based around specific demographics, or, how do we detect anomalies in data and figure out what to do with them, right? Sales campaigns, obviously there's a lot of value in there, and many sales departments and marketing teams are looking at ways to enable big data to help them understand their market better, and obviously more sentiment analysis here, right? It's a kind of a recurring theme. And then we've got oil and gas, right? So now oil production, things about the environment, things about the area, what do we have available? How do we maximize those natural resources that are available to us, as well as, things like we get into surveying the land and going through and understanding, our wells starting to wane, our operations slowing down. Do we need to start looking elsewhere? What are the signs of that, and do we have that captured? supply chain optimization. Where should this oil go? Where should it be? Where should it be refined? What's our best option here? What roads should we be taking? All kinds of stuff like that, right? Sensor data. I mean, there's some great stories out there about how like Shell Oil is using drills that have IoT sensors on them that are able to tell the engineers that are running the drills when a drill bit is going to fail, and if they're able to extract that drill bit before it fails, the amount of time and money that is saved is just astronomical. And so they're keeping an eye on those sensors to make sure that they're able to avoid those failures and the prolonged downtime. And then obviously, again, recommendation engines, sales and marketing analytics, and that's sort of all encompassing. And then finally, security, right? So we're seeing this being adopted more and more, where you've got these aggregated environments like a SIEM, or there's some very popular ones out there. We've got Azure Sentinel that allows you to do some anomaly detection and things like that. At Microsoft, we use Databricks for our Azure Data Factory data flows component, where we're able to take advantage of that Databricks compute platform with a visual environment that the code is being basically taken from that visual environment. It's converting it into Scala that then gets processed on Databricks, right? So taking actionable insight, actionable intelligence based on what we're seeing within our own environments, and what can be done to prevent this in the future. What can be done to prevent a current leak or hack or whatever, any kind of fraud analysis or risk analysis, right? So what patterns are we seeing that could be somewhat malicious, or could cause further harm down the road? Who's just poking into our network as opposed to trying to break in, and what are some of those patterns that we see over time, and how do we avoid them? Compliance is a big one, right? And are we able to see everything that's going on in our environment, and how do we avoid being hacked, and also how are we able to keep everything in one location where we can kind of keep an eye on everything at one time? And then identity management and fine-grained data access, right? So again, we want to make sure that we're keeping a watch on what's happening there. So now that I've got through that, we can go into the demo into the portal. And so essentially, when I go into my Azure environment and I want to create a resource, if I just type Databricks, Azure Databricks comes up. I hit create. Very simple. Specify, what my workspace name is, what subscription I want to use, if I've got a resource group, or create a new one, where I want it to be, and then they've got 3 different tiers here. So basically, you've got a trial tier that allows you 14 days of just use. So if you've got an Azure environment, definitely go out there, search for Databricks tutorials. There's some really good ones on both batch loading and stream processing. And feel free to reach out to me, and I can point you to those as well if you have any questions on that. But then you've also got your standard and your premium tier. The big difference there is that the role-based access control on the premium tier. Okay, so you specify your details here. Very, very simple. You hit create, and that takes probably 5 to 10 minutes to spin up. And what you get is this environment, right? So where basically it pops up and says, okay, we created this. And here we're going. Yes, sir.
You got the wrong screen up. It says the demo doesn't have the Azure portal.
Oh, sorry, man. Thank you. Let's go back. There we go. I don't know how that happened. Anyway, let me go back to here real quick. All right, so create a resource. Thanks, Jason. Databricks.
You're welcome.
Hit create. Again, so we've got your workspace name, just very, very basic details to sign up and set up. You've got your pricing tiers, so standard, premium, and trial premium. Again, the only difference between the premium and standard is you get the role-based access control. So it really depends on what your environment is, what you need. You hit create, comes up 5 to 10 minutes later, and then you get this screen when you go in to click into the resource. So from here, again, this is different from other cloud providers where we are giving you one seamless experience where you're working all inside of your Azure tenant. You launch your workspace and that opens your Databricks environment. So you can see this has now redirected me to my eastus.azuredatabricks.net environment, right? And so I'm actually in the Databricks Azure environment now. Within here, you can see there's common tasks, this is your dashboard that you start up. You can pin things here to get to it more quickly and those types of things. So a few things that I want to show, essentially, you've got your home environment, which gives you your user folder, right? And so it's going to give you anything that's inside of your own personal environment. But you can see there are shared environments, and there's some built-in training and tutorials that you can get as part of this documentation and those types of things. And so then as you drill down and you look at your workspaces, you'll notice that didn't really change because we're looking at who the users are. So if there are multiple users within my Databricks environment, I would be able to see their names. I might not be able to access them. It kind of depends on what access I've been given to those various environments. But then within my workspace, I've got my user account, and then I can go from here. I can create new folders. I can create a new library, and build an experiment directly from here if I need to. What I want to show real quick is how to create a new cluster. So I've got one here. We'll get this one started. So if I've got time, I can show what the environment looks like. Now notice I have it set to shut off after 10 minutes of inactivity. That's why I had to start it new here. But if I want to create, did I not start? It should be starting. Yeah, it's starting. So I've got my little icon there telling me it's pending to start. So if I want to create a new cluster, though, just create the name, what the mode is here. Is it going to be in a pool of resources, specifying my Databricks runtime version, my version of Python. Do I want it to auto scale, right? So I get the option down here to set my min and max workers. If you turn auto scaling off, then it's just going to assign however many worker nodes you want to be included. And then I always set this in a terminate after 10 minutes of inactivity. It defaults to 120 minutes. I definitely recommend setting it down to 10 because unless you need that running, you're just burning compute and it's costing you money. So I definitely recommend bringing that down to 10 minutes because if you walk away or you get distracted, you don't want that just burning in the background. And then you've got some advanced options here, so you can set up some tags. You can do some more detailed environments like around the environment variables or setting up your Spark configuration, things like that. You've got tags about the environment, so if you want to add tags to this cluster, for one example would be like PII data, and if you're processing PII data through this and you wanted to tag that as something going on there. You've obviously got your logging here, so you can say where you want to send that log path to, and then if you've got any startup scripts or anything like that. So once you create your cluster, again, probably takes about 10 minutes or so to create a cluster. It'll show here in this interface. And basically when I want to, say, load a notebook, now I won't have my cluster available. You can see it's still starting. We'll see how long it takes to start up. But essentially, I've got cells inside of my notebook. I've got the ability here either to run all of the cells, and so these are basically chunked up into commands. I can add a cell in between if I want to by just hitting this little plus button here, and it goes away. You got to kind of hover in the middle. But so what I'm doing here is part of these operations is, I'm basically connecting in to a blob storage account where I have a data file sitting. And so, this is sort of this is my name and this is my key. And then I am running some code on setting up the structure of the file. So exactly how I want it to be sitting in when I load this into memory so that I can do more operations on it. And so I'm, specifying what the schema looks like and, what the file type is. We need CSV down here, and then where it's coming from. So it's this New York NYC taxi data at, and then my data lake name, right? From there, I'm just doing a display, so I have loaded the contents of this file into memory, essentially into a frame. And then from there, I want to display what that data is. So I've set up the structure, I've showed what the schema is, and then I'm looking at the details of the file here. And then I'll go through and I want to run some SQL operations on this file. And so, sorry, I'm actually loading it into a view here so that I can run that SQL operation in the next cell down. And then it'll allow me to do a count. My cluster has now turned on, you can see, so I've got the little green dot here and it says that this notebook is attached to my cluster. Note up here that it says that it's a Python notebook, and within this cell I am specifying that I'm using SQL language, and I'm doing just a very basic select count star. There are let's see, 100 million, 102 million, 804,000, 250,000 records. If I hit Shift Enter here, I can run that and see how long that takes to run. Run the count operation. Should go pretty quick. This is going to bomb out because I didn't load the data into memory and it wouldn't have persisted. So, all right, we'll go back to that in a minute here. And then we're just running some basic SQL operations again. So in that cell, I'm specifying that I'm using SQL. I'm, further trimming the data that I want to see as a result of this. So I'm going through and filtering just some records based on, what the date of the pickup was, what time they dropped them off, how many passengers were in there, and what was the total amount of the fare. And then I want to go through and, I want to use the visualization aspects of it here to show, what percentage used credit card versus cash and, those types of things. And so essentially it gives me the opportunity to very quickly just run a regular SQL command. You can see there's nothing special about this, nothing fancy about it, just a regular old case statement, and doing, dividing it up amongst that and then showing the results. And so I did error out up here. So what I need to do is actually, if I run all, basically it's going to go through and it'll start from the top. It'll send the data down, and then you can see this one command took 0.06 seconds. This command took 4.91 seconds. This one is running and showing the first 1,000 rows, so it's 7.73 seconds. This took 0.09 seconds to create the temp view. I'm running the select star. This will take just a minute. You can drill in and see exactly what's happening down below. So it kind of gives you a little more detailed information as to what's happening here. And then we'll go through. So and the next subsequent command is waiting for the previous cell to finish. And finally, we'll go through and revisualize this. So I think we get the idea there. So typically, if I'm going to run the cluster, if I know I'm walking away, I'll just shut it down, which basically all I have to do is you can detach and reattach if you have an issue. You can detach the notebook from the cluster itself, but then in order to shut down the cluster itself, you have to go back to the cluster operations, and you've got a little stop button here to terminate it. You can also clone the cluster, so you can use the same settings and you can clone it, which can make it a little easier for you. If you want to do that, let's go back to my notebook. Let's see where we're at. Okay, so it took 1.13 minutes to run that count operation, which sounds a little long, but and now we're doing my filtering. Almost there. While this finish up, so essentially, imagine, if you will, you want to run a Databricks job, say inside of an Azure Data Factory, and you want to process data as part of or as a result of a Data Factory pipeline. You can specify that you want to execute a notebook inside your Databricks environment. So you can go, the Data Factory can reach into your Databricks environment. You can specify which notebook you want to run, and you can have that as part of your data preparation step. So if, for instance, you want to take data from after you've ingested it using Data Factory, you landed it in Blob or Data Lake Store, and then you wanted to use Databricks to do the data processing itself, and then land it back into Blob or put it into SQL Data Warehouse or wherever you want to put it. This can be a step as part of your Data Factory pipeline to use a Databricks job. So this would be a great example of that, right? So if I wanted to run some job and, I wanted to, instead of visualize it here in this environment, I wanted to run some additional operations and visualize it directly in, so, say, Power BI, that would be an option for that kind of thing. So if I go back to my slides again real quick here, just to wrap up. Oh, that's good. Start me from the beginning. Let's do it this way. So now, just to kind of wrap up, what does make Azure Databricks better, right? So that was the title. And so really it's these 5 things, right? You get the speed to process the massive amounts of data in memory with that auto-scaling compute. It's the flexibility to choose from many different programming languages and handle batch and or streaming loads within the same job. You've got the integration of all the APIs and libraries for all of the Azure services and hundreds of open source tools that have been developed. You've got that security with the granularity of Azure Active Directory integration to be able to directly interface with those users. And then you've got the compliance, being that Azure is the most compliant public cloud. So how do you get started? So you can go in. I showed you how to set up a Databricks workspace. You can work with your Microsoft Teams directly. You can reach out to me. You've got my contact info, and just go to azure.com/Databricks to get some more information there. And with that, Jason, I'll hand it back to you.
All right. Excellent. Thanks, Chris. And we actually do have a large number of questions, but we are at the end of the hour. So what probably makes the most sense is if folks want to take down Chris's contact information that's on the screen there,
let me go back
and reach out to him directly.
Yeah. Let me go back to the let me go back to the first page. You guys can have my email and stuff. Definitely happy to help out with those types of things. And then maybe Jason, I don't know if there's a way that we could post a question and answer after the fact. That might help some people out after I aggregate some of those to go back and look at the session after. Okay, perfect.
Yeah, absolutely.
So
I'll keep track of those and I'll send them over to you. And
awesome. Yeah, that'll be great. And then I can answer them that way. We'll get those posted in the next week here or so.
All right, sounds great. Thanks for the presentation here today, Chris. Thanks everyone for attending, and have a great day.
Yeah, thanks a lot. Take care, guys.